So we're going to look at quadratic patterns here, and one of the things that we'll investigate is how you can tell the difference between a quadratic pattern and a linear pattern, but we will get to that. What I've got here for you is kind of a simple diagram. Each of these dots represents a airport in a different city. And depending on how many dots I have, I've got a bunch of different routes that I can fly between for the different cities. So for instance, for 2 airports, I only have basically one flight that I can take between them. So the number of airports in this case is 2, and the number of routes is 1. If we looked at another example, if I have 3 cities, the number of ways that I can fly between these 3 cities, well, 1, 2, 3. And in this case, you can see that I've connected every single city with the other cities in the group. So from any one of those 1 cities, you can fly to the other 2. And that gives us a total of 3. So for 3 airports, we'll have 3 routes. Let's look at the next one. From here, I could fly to that city, and to that city. So that's 3. And then I could fly over here for 4, 5, and 6. So with 4 airports, or 4 different cities, there's 6 different flights I can take to get between those 4 different cities. And if we look at our last pattern given here for 5 airports, again thinking about connecting 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So you get a nice little star in there, and in that case, with the 10 different flights, you'll be able to fly between any of those 5 cities. So 5 airports gets us to 10 flights. So once we have our table filled out here, let's investigate. And if you remember with linear patterns, one of the things that we look at in the very first instance is to find the first difference. So let's take a look at our first difference here. So the first difference between 1 and 3 is 2. And between 3 and 6, that's going up by a total of 3, so I have a difference of 3. And from 6 to 10, that's a difference of 4. So my first difference here is not constant. And so I know automatically I do not have a linear pattern, because I have to have a constant first difference to have a linear pattern. So I'll go one step further, and let's investigate what happens with our second difference. And the second difference means take the subtraction, or find the difference between the first difference. So between 2 and 3 we have a 1. Between 3 and 4 we also have a 1. And I suspect if I had more numbers in here, like if I had investigated 6 airports and 7 airports, I would see that the second difference is the same. It's 1 every single time. So we can tell if a pattern is quadratic if the second difference is constant. And again, that means that it's not changing, so it's 1 between every single first difference there. And so we can see here that the second difference is constant. So we have a quadratic pattern. And what we want to do is actually find this rule, so let's do that. Find the rule. So we'll find the relationship between the number of airports and the number of flights that can exist between those. So it is possible to do these by hand, but it is kind of cumbersome. So I'm going to actually go straight to showing you how to do this on the calculator, because it's in the end how most of you will do it. But if you want to look at how to do it by hand, you can talk to me about that in class as well. Okay, so if you get your calculator up, I have, where do I want to put this? I've written down a few of the instructions there, which again, you should get the hang of. So first thing that we need to do is go into stat. So again, that's from your menu, find stat, press your execute button, and you need to enter in the points that you've got. So we're going to enter in, again, these are the points out of the table. So starting with 2 in this case, 2, 3, 4, 5, I'm just entering the x ones first, and then I'll go over and enter the other ones. Sometimes that's easier than flicking back and forth between the sides. Just make sure that they match up, so 5 and 10, 4 and 6, 3 and 3, and at the top 2 and 1. And for a quadratic pattern, keep in mind that you need at least 3 pairs of points. If you put in more, that's okay, but you don't have to put in a billion. 3 will make it work. So the next thing for us to do then, if you're coming at this from the start, would be to hit graph. So F1, hit graph 1 again, F1 again. And here we're going to look at calc. And I guess that should be on this one here. Some little tips for you guys. So after we've hit graph 1, check, does it actually look right? So let's think about this. I don't know if this looks right because I don't have it plotted yet. But if I pay attention to that, does it look like a straight line? It doesn't. It is slightly curved, so I'm thinking it might be quadratic. And I know it is because my second differences were constant, but that's okay. It should be curved. Quadratics will be curved. And they kind of look like they follow a pattern. There's not one point that looks, totally out of the way. Like if this point here was really high and was a giant step up and down there, you'd know something is wrong. So it's just a good place to dummy check. We're going to go ahead and hit calc. And then in this case, if you're using a linear pattern, you would hit x. But here we're looking for x squared because this is a quadratic. Remember, quadratics and parabolas have an x squared in them. So here we're going to hit x squared, and we're going to get our rule. Again, using substitution, a goes with the x squared term, b goes with the x term, and c would be the constant. And another check for you here is that I want you to make sure that your r value is equal to 1. So let's look at that, our r squared value. And you can see the r squared value here is equal to 1. And again, that will only be on the newer calculator models. But if it is equal to 1, you've got a pretty decent shot, especially if you've put in, 4 or 5 points into there, that it's probably the right equation. You didn't do anything wrong or silly. So what we need to do is write down what we've got. So we've got y is equal to 0.5 x squared plus negative 0.5 x squared, or x, plus 0. And I might just write that as minus 0.5x. So I'll write down what we've got. Y is equal to 0.5 x squared minus 0.5 x. You could write the plus 0, but we don't really need it, so you could also just delete that if you want. Now remember, you want to get this into context for yourself. So if we remind ourselves, in this table, it's always x first and then y. So let's replace the x and y letters with a and r, because a stands for the number of airports and r is the number of routes. So y is equal to r, so we're going to say r is equal to 0.5 a squared minus 0.5 a. And I'll leave off the plus 0 because I don't really need it there anymore. So again, just to recap that one more time, we go through stat. Make sure you enter in your points. You need at least 3, pair them up. Little check here. If you by chance get a error like, oh, it's not going to do it. I thought it would be able to show you something, but it's not going to error it out. Okay. Make sure that your points match up the whole way through, that you've got equal numbers down each side of the list there. When you get to graph 1, make sure you take a look at it, calc. And if it's quadratic, it's x squared, so we hit x squared. Again, my r squared there is equal to 1, so that's good. And just to show this one point for you guys as well, if you're kind of in a rush and you're not paying attention and you just go calc and then you think x, because you're used to it, this is a good example of r squared not being right. So my r squared value here is not equal to 1, so it tells me this equation doesn't actually fit all these points. It's just the best you can get for the rubbish that you've given it. And again, a straight line is not going to work for a quadratic pattern because a quadratic pattern is curved, so there's no way that you can get a straight line to work for that. So it's just an example of how the r squared can help you catch if you've done something that you're not supposed to do. So again, it should be calc x squared for a quadratic, and there you see the r squared is equal to 1. Now that you've got your rule, you're in good shape, you can go ahead and use it for the rest of the problem.